In this video, we're going to be starting topic 7.1, which is modeling situations with differential equations. So we're going to answer the question, how do I write a differential equation to model a situation? And I can write a differential equation to model a situation is what we're going to be able to do. So this unit contains one of the most important applications of calculus, differential equations. This is not new to you, hopefully, if you're in BC. So a differential equation in x and y is an equation that involves x and y and the derivatives of x and y. A solution to differential equation is a function that satisfies the differential equation when the function and its derivatives are substituted into the equation. So the solution has to be a function that satisfies when the function and its derivatives are substituted into the equation. A solution to a differential equation could be one singular function, okay, or a set of functions, which we call the general solution. And we will get more into those as we go throughout the unit. So these are some examples here of differential equations. It's basically an equation that has the derivatives in it already. And you'll notice I've got second derivatives, I've got first derivatives, I've got them in dy dx form, I have them in prime form. So those are all equations of differentials. So you're going to see sometimes you'll see a multiple choice question that looks like this, if you understand the words that are in it, it's actually an easy question to answer. So this is something here. It says recall, but it's not likely something that's been in our high school math curriculum. You may have seen it in middle school, but again, with Common Core, it's kind of cut out in places. So let's understand what this is. And once you understand the definitions, these problems become very easy. So direct variation, okay, occurs when a situation gives rise to a linear function. So notice what the function looks like. It looks like y equals, or f of x equals k of x. So you're multiplying. Where the k is the variation or constant of proportionality. We say that y varies directly as x, or that y is directly proportional to x. Then the other words that you might see in a problem is inverse variation. This occurs when a situation gives rise to a function, and look at the functions. It's the constant divided by the variable, where k is the constant of proportionality. We say that y varies inversely as x, or y is inversely proportional to x. So let's look for those key words. So really what it is direct is multiply by k, okay? Inverse is divide by k. So those are the things that we're looking for when we're doing these problems, okay? So a particle moves along a straight line. I'm looking at example 1. Its velocity is inversely proportional to the square of the distance. So we're talking about square of the distance it has traveled. Which equation describes this relationship? So first of all, I am looking for velocity. And there's two different things here. I see velocity and I see the derivative of velocity. So since it's specific about velocity, I'm going to get rid of my derivatives of velocity. Then I am noticing that it's supposed to be the square of the distance, but they were explicit that the distance was equal to s. So it has to be the second one, not the first one. And notice it said inversely proportional. They gave them to us all as fractions. I was expecting to have to be able to tell the difference between the two. So let's look at example 2. A puppy gains weight, W, at a rate approximately inversely proportional to its age, T, in months. Write an equation that describes this relationship. So keywords in there was inversely proportional. And then something else that you want to take note of is they give us the weight, but they want it at a rate. So whenever we're talking about rate, that means I want a derivative. So I'm looking at dw, and with respect to time, dt. So the equation is going to be a dw dt, which is way different than what we saw in example 1. They were very explicit about saying velocity in example 1. All right, so it says that we're supposed to be inversely proportional to its age. That means my variable has to go on the bottom, and my variable that would be acting like my x is my t. So my t has to go on the bottom. We always use k for our constant of proportionality. So it would be dw dt equals k over t.